Tesla has made impressive progress with its Optimus humanoid robot. According to Elon Musk, there are concrete plans to have more than 1,000, perhaps even a few thousand, of these robots operating in Tesla facilities soon. He recently stated that Optimus is already capable of moving autonomously in about 95% of complex environments and reacting to stimuli in just 20 milliseconds. With this, the company is preparing for mass production. The goal is to manufacture 10,000 units of the third-generation Optimus by 2025. To make this ambitious plan possible, Tesla is leveraging its entire AI infrastructure, manufacturing capabilities, and a robust base of practical tests across more than 1,000 real-world tasks. And in this episode, we'll analyze official data, technical demonstrations, and concrete evidence to understand whether this project is really ready to get off the ground. Later, you'll see a price analysis, and, in the third part, the full launch schedule. But first, it's essential to understand what the Tesla Bot Gen 3 promises to deliver, and above all, whether it's really worth the investment. Imagine the following situation. John Kennedy, a man in his late 70s, is lying on the floor. He is experiencing severe pain in his back and hips, and he has no strength to move. His cell phone is nearby, but out of reach. Everything goes dark. It is at this moment that a humanoid robot detects his fall, carefully approaches him, gently lifts him up, assesses his injuries, and immediately sends an alert to the attending physician. The doctor's recommendation? Admission to a care center. But John refuses. He doesn't want to live in a place where he would be just another elderly person waiting for time to pass. What if there was an alternative? The Optimus Gen 3 was designed to be that alternative. It doesn't take away autonomy. Indeed, it supports you with dignity. It makes drinks, organizes the house, folds clothes, and even knows when it's time to just sit quietly by your side. It can accompany you on a walk or cook a plate of pasta in less than half an hour. That way, John could continue to live in his own home, safely and independently. This is the future that Tesla is bringing closer to us, and it's closer than many imagine. As promised, we'll soon reveal all the details about the production plan and the official launch schedule for the Optimus Gen 3. But before that, let's understand how Tesla is ensuring that this robot is truly ready to face the challenges of everyday life. After all, is it really useful? What exactly is it capable of doing? Optimus Gen 3's design is based on an artificial neural architecture derived from Tesla's self-driving system. This allows it to interact with its surroundings in real time. According to researcher Milan Kovic, the robot's internal controls operate with a latency of just 2 to 3 milliseconds, updating its state up to 500 times per second. This means it can anticipate situations rather than just react to them, a skill Elon Musk describes as future vision. When descending stairs, for example, the robot not only adjusts its steps, but also anticipates the body movement and balance required for the next 3 steps. This drastically reduces the chances of falling. The stability and precision of this movement are essential for real-world environments. This level of anticipation is complemented by a multimodal sensor system. The robot's head features a 360-degree camera array, similar to those found in Tesla vehicles. And its hands have tactile sensors that are sensitive enough to hold a raw egg without breaking it, but also agile enough to easily catch a tennis ball midair. During recent testing, a curious leak emerged. The Optimus Gen 3 successfully managed to fry an egg. It demonstrated the ability to adjust the strength of its hands when switching between gripping a cold cardboard box and a hot frying pan, all in real time. The mechanical improvements in this third generation represent a huge technological leap over previous models. The hands, for example, now have 22 degrees of freedom, twice as many as the previous generation, and can perform 47 of the 50 tasks with human-like precision. The new motors and artificial tendons offer movement accuracy of up to 0.1 millimeters, as seen in a viral video in which the robot can thread a needle completely autonomously. This paves the way for highly sophisticated industrial applications. This impressive dexterity allows the Tesla bot to perform high-precision tasks, such as assembling electronic boards in industrial settings. At home, it is capable of handling delicate objects with extreme care, folding clothes or arranging flower arrangements, for example, with surprising precision. Advances in mobility are equally remarkable. The latest models can handle slopes of up to 45 degrees and descend stairs fluidly, something previous versions could not do efficiently. This was only possible thanks to actuators inspired by human biomechanics, especially in the ankle region, which adjust the stiffness of the joints in milliseconds, even before the foot touches the ground. And it's not just theory. Tesla has released videos on its official X account, formerly Twitter, showing Optimus traversing hills covered in gravel and uneven vegetation in its test field. Elon Musk highlighted that the robot handles unstable terrain with the help of neural networks that control each limb autonomously, without relying on remote control. Milan Kovac, vice president of engineering for the Optimus project, highlighted a curious detail. The robot maintains its balance even without relying on vision. He even slipped on the ground where Optimus was walking firmly, which reinforces the level of sophistication of a locomotion system. But after all, how much does this humanoid robot cost? During the CES Technology Trade Show, the hallways were lit up with thousands of LED screens and cutting-edge robots on display. Among the visitors were Jenny and David, a couple who walked slowly, observing each innovation with curious eyes. When they watched a promotional video of a humanoid robot with great agility and the ability to interact, they were fascinated. It wasn't just a household helper. The robot could talk, remind people to order medications, and provide companionship to the elderly, helping to ease the emotional burden on families. Jenny quickly imagined the machine organizing the house, helping David with heavy chores, and caring for her hyperactive grandson. The future seemed closer and brighter. "How much does it cost?" David asked a little apprehensively. With a friendly smile, the attendant replied, "The standard version costs $140,000, but we have financing and installment plans available." David sighed and looked at Jenny. "So what? Can we do it?" This is precisely why Elon Musk's proposal to launch the Tesla Optimus for less than $20,000 is causing quite a stir in the robotics sector. The strategy is not just to reduce the final price, but to revolutionize the market through three main pillars. Reduction in battery costs. Tesla's large-scale production of 4,680 cells makes it possible to significantly reduce the cost of this essential component. Part standardization. Around 78% of Optimus parts are shared with Tesla vehicles, which optimizes the entire production and research chain. Monetization via software. The company plans to offer premium features via monthly subscription, such as AI-powered personal assistants, elderly care protocols, and educational support. Initially, giant companies and health networks are expected to be the first customers. However, Tesla is already developing a home version, aimed at the average consumer, with functions aimed at child safety and even the ability to learn cooking recipes. According to a leaked memo from a major U.S. retailer, the Tesla Optimus Gen 3 is slated for release in Q4 2025 with a suggested retail price of $19,999, plus an optional AI services plan for $199 per month. In today's robotics landscape, Boston Dynamics Atlas is still considered an engineering masterpiece, often touted in research centers as a symbol of technological advancement. However, its exorbitant price tag of around $2 million and its low commercial scalability seriously limit its impact outside the lab. On the other hand, Tesla's Optimus model, especially the third generation, emerges as a revolutionary alternative. Thanks to Tesla's fully integrated production model, each unit costs just 1% of the price of an Atlas, with the advantage of integrating artificial intelligence in a much more advanced way. While the Atlas relies heavily on pre-programmed routines, the Optimus learns new tasks by observing and using reinforcement learning. A practical example of this was when the Gen 3 taught itself how to operate an espresso machine, simply by watching a barista in action. Asian competitors, such as Unitree and Fourier Robotics, have even launched humanoid robots at more affordable prices, ranging from 50,000 US dollars to 100,000 US dollars. But they do not have the AI infrastructure developed by Tesla. Their solutions generally perform tasks based on predefined commands. Optimus, on the other hand, is capable of adapting in real time to unpredictable situations. In a live demonstration, for example, a prototype of the robot stopped its task when it noticed a spilled liquid, fetched the cleaning materials, and only then returned to work, all autonomously, without any human interference. Now that the price seems more affordable and justified, the big question arises: will ordinary consumers be able to buy the Optimus? Or will all production be absorbed by companies by 2025? Will individuals even be able to make a reservation? Let's get real. Tesla is aiming to build 10,000 Optimus units by the end of 2025, a clear indication that the company is serious about scaling humanoid robotics. While Elon Musk acknowledges that this is a bold goal, he says that even delivering a few thousand units would represent a milestone. Initial production will begin at Tesla's Fremont, California, factory, which is already gearing up to build the first 1,000 units in the first quarter of 2025. From there, the goal is to gradually scale up production to 10,000 units over the course of the year. This staggered approach follows the same model that Tesla adopted in its early years with its electric cars, encountering initial bottlenecks, learning from them, and then accelerating exponentially. Tesla is confident in this plan because it has expertise in key areas such as batteries, motors, and artificial intelligence systems, all of which are part of its experience with autonomous vehicles. Many of the sensors and actuators used in Optimus come directly from technology in Tesla cars, which makes the production process more efficient and cheaper. Furthermore, Elon Musk has already confirmed that the assembly lines for the third-generation Optimus are being designed to scale up to 100,000 units per month from 2026, signaling that the company is betting big on global demand. Critics still question whether Tesla will be able to meet this ambitious timeline, especially considering previous delays on projects like the Roadster. However, the context is different. Unlike the Roadster, which required a new supply chain, the Optimus already relies on Tesla's existing partnerships with battery and chip suppliers. And the retooling of the Fremont factory to produce the Cybertruck served as a dress rehearsal for rapidly scaling up robotics production capacity. Elon Musk recently revealed that Tesla is already putting Optimus prototypes to work inside its own factories. These robots are being tested in simple logistics tasks, such as fetching parts and supervising parts of assembly lines. This practical testing environment gives Tesla a strategic advantage, mainly because of the vast amount of data that the company already accumulates. With more than 5 million vehicles on the road around the world, Tesla is constantly collecting real data that feeds and refines the artificial intelligence systems used in the robot. This exchange of knowledge between Tesla's automotive and robotics divisions creates a continuous learning cycle. For example, navigation algorithms developed for the car's self-driving technology are being adapted to ensure Optimus navigates efficiently in different environments. And Musk's vision goes far beyond 2025. He predicts that eventually Tesla will be able to produce up to 100 million Optimus units per year, making robotics the company's largest revenue source. While that number may seem exaggerated at first glance, the economics are solid. With an estimated selling price of around $220,000 per unit, a figure that would become feasible if it produced 1 million robots per year, Tesla could generate as much as $20 billion in annual revenue from Optimus alone. Tesla has already defined 5 main areas where the third-generation robot will be used. In industry, it will be responsible for repetitive tasks, such as separating parts and quality inspection. In the healthcare sector, it will help transport patients and deliver medicines. In retail, it will be able to organize shelves, control stock, and assist in automated sales processes. In domestic environments, Optimus is being prepared to cook, clean, and even help with childcare. All of these applications are already in the final testing phase and should reach the market in 2025. Another area Musk is already looking at involves using robots to maintain future Mars colonies, led by SpaceX. Instead of relying on human labor, Engineers are adapting robots to withstand extreme conditions on the red planet, with sealed joints and radiation-resistant electronics, with the goal of building space habitats autonomously. Initially, there were rumors that Optimus would be exclusively for internal use at Tesla factories, with no plans for the general public. But that has changed. Today, around 1,000 humanoid robots are already in operation at the company's factories, performing tasks that not only help speed up production, but also generate crucial data to further improve manufacturing processes. And that number is expected to grow dramatically soon. Recent reports indicate that Elon Musk is much more confident about the project's progress, and it is estimated that the ratio of robots to humans within factories could reach 3, for even 5 robots for every employee. On a global scale, that could mean between 20 and 30 billion units over time. Despite Tesla's reputation for delays on past projects, such as some electric vehicle models, development of Optimus is moving forward at a surprising pace, faster than many experts expected. The company is ramping up production of the first generation, perfecting the second, and preparing to officially unveil the third generation of the robot later this year. So far, Optimus has only demonstrated a small portion of its true potential. At a recent Tesla presentation, the robot roamed a live production line filled with workers and machines, demonstrating its ability to navigate independently in a dynamic and unfamiliar environment. Just as a human might hesitate when entering a new location, the robot also assesses its surroundings before making decisions. But it does so fully autonomously, interpreting machines, people, and the space around it to navigate. This ability makes Optimus a valuable asset to Tesla's manufacturing operations. And Elon Musk isn't the only one betting on the potential of humanoid robots. Investors from around the world are pouring millions into robotic startups, eyeing a market that is expected to surpass $38 billion in value in the coming years. By 2035, new robotics companies are emerging at a rapid pace in North America, China, and Europe, an unprecedented growth in the industry. But what really sets Tesla's Optimus apart is its ability to produce at scale. According to Musk, Tesla designed every component of Optimus in-house, from the actuators and robotic mechanisms to the electronics and battery systems, all developed by the company's own engineers. This vertical integration allows Tesla to scale production quickly without relying on external suppliers. It is this autonomy that gives Musk confidence that Optimus can be sold at a price well below the industry standard, with an estimated production cost of just $10,000 per unit. Tesla's progress with Optimus has been impressive, and if development continues at this pace, personal robots could become accessible to virtually anyone, like having an R2-D2 or C-3PO in your home. With an estimated price of around $19,999, would you be willing to have a robot living with you, taking care of your family, and even looking after your children? And what do you think of Elon Musk's prediction that 100 million Tesla bots will be manufactured annually? Leave your opinion in the comments. Thanks for watching. If you want to learn more exciting news about Tesla, its electric cars, or the Tesla bot, don't forget to like, share, and subscribe to the channel.